So this image we see here is an example of a diffraction pattern. Some characteristics of the diffraction pattern are these alternating light and dark spots. And you can see these different levels of them. You can also see the appearance of a bright spot in the middle, and that the intensity of all of these bands decreases as your distance from the middle increases. I also want to point out there's a circular ring around that center bright spot, and all of that is going to be laser scatter. Finally, let's take a look at a clean diffraction pattern of the laser diffracting around a smooth, thin wire. Notice how we have an elongated spot in the middle of this pattern, that the intensity decreases as we increase our distance from that center dot, and that it's very periodic. All of these spots of light are about the same width, and while their intensity changes, their spacing doesn't really. And that spacing is what I'm going to measure and use that to calculate the wavelength of this laser. In order to record this pattern, I'm simply going to put a piece of paper on the wall and then use a pen and mark both the inside and outside edge of all of these spots of light. And by measuring the distance between each of these spots, I'll be able to compile some data for analysis. Now the only thing left to be done is to repeat the process with the other two lasers. Now, after all that drawing, I have 3 diagrams illustrating the diffraction pattern created by each of the lasers. To do the data analysis, I had to measure the distance using a ruler from the center point to the center of each diffraction gap, so the area where there was no light present. And so to do that, I simply measured the distance to the close and the far edge of the marks that I had made, and then said that the average between those two was going to be the total distance for that particular diffraction order gap. Then, using a relationship I'll show in a minute, I calculated a wavelength at each order. So each of those dark spots on the diffraction band represents an order. So there's a wavelength associated with each of those bands. That's not to say that the wavelength is different. All that indicates is that the accuracy of each measurement is limited at each order. So in order to get an accurate wavelength measurement for the laser, you should measure a wavelength appropriate for each order and then average those. So you can see I did that on a spreadsheet, went through as many orders as I could, calculated a wavelength, and then took an average. After making these calculations for all 3 lasers, here are the results. Notice that the error or standard deviation of each measurement decreases as our wavelength decreases. However, the question deserves to be asked, how accurate is all of this? So I decided to take each of those 3 laser pointers and bring them to my lab where we have a spectrometer where I can accurately measure the output spectrum for each laser. And as you can see, for the blue and the red laser, the calculations are actually pretty spot on. I don't necessarily have a good explanation for why the green laser is so far off. I imagine it's something I would have to retry again. It could also be the case that I didn't quite draw the center very accurately, which could also lead to a systematic error like this. Before I close, I just wanted to show a couple really cool photos that I ended up taking during the course of this project. As you can see here, this is a picture of a single laser beam shooting down my hallway. But as soon as you put the wire on, you get the diffraction pattern. And you can actually see that. As I missed this area with a water bottle to take a picture, you can see all the individual diffraction lines alongside the main laser beam, which I just thought was a really cool photo, and it was cool that you could actually see those beams traveling in space, the waves expanding across the hallway, which I just thought was really neat. And that's everything I have for this video. I hope you enjoyed it, or at least learned something new that you didn't know before. Thanks for watching.